Now we are going to talk about extracting information from a linear model. When we summarize a linear model, a lot of information is output into the console, but we may need to get different pieces of the model to continue exploring the data. Now let's rebuild a linear model from a previous lesson. I'm going to run this short little bit of code, which is going to load the Cars 93 dataset, attach it, and build a quick linear model. So let's look at a summary of the model. And you can see a lot of information. So now we need to know what pieces of this model can we extract. Let's use the attributes function to see how many different pieces there are to this linear model. For example, if we wanted to extract the coefficients, we would use the dollar operator after the linear model object name, followed by the coefficients attribute. We can also use the COEF function, which of course stands for coefficients. This works similarly for other attributes of this linear model. For example, I can extract the residual of each observation using the dollar sign followed by residuals, or I can use the residuals function to pull them out. Here's a simple plot of our residuals. If you want the fitted values, you can pull those out as well. Now let's create a scatter plot with weight as our x coordinates, and we'll use the fitted values as our y coordinates. And we'll use points, and we'll make the color blue. Now we can add a diagonal line using the abline function and entering in the coordinate 1, 1. So this plots an x equals y line on the graph, and it can give us a quick look at the spread of the predicted values. Generally, it is good practice to split up data into a training and a testing dataset. So let's randomly split the Cars 93 dataset into a test and training set. So for this, we're going to use the sample function, which is going to randomly pull different row numbers of the Cars 93 dataset. The size argument will tell us how big we want the sample to be. And in this case, I'm going to multiply the number of rows times 0.75. And this will return 75% of the rows. I then round that information just in case there's a decimal place. And with 93 rows, it's really hard to get 73% of that. There's most likely going to be a decimal. And we would like it to be an integer. So now we have a training index, and all I have to do is subset the Cars 93 dataset using that index. And then for the test dataset, which is 1/4 of the information, we simply have to put a minus sign in front of the training index. If you look up in our environment, you can see that we have a test dataset and a training dataset, and the training dataset is 70 observations, while the test one is 23 observations. So what we will now do is train a linear model on the trained cars dataset and apply it to test cars to predict their weights and see how well it performs. So I've attached the training dataset, so I'm going to use the same model that we first ran in the beginning of this lesson. So we can use the predict function on our model to get the predictions of our in-sample or training dataset. This is the same as the fitted values of the model. So how can we submit new data to the predict function? Let's create an object called test_predict. We're going to use the predict function, throw in our original model that we created from the training dataset, and we're going to set the argument new data to equal test cars. So we now have predictions for our out-of-sample data. So how do these predictions line up with the actual values? We'll have to go back and use the training index to line up actual and predicted values. So here, what I'm doing is I'm pulling out the weight information from our test rows. And then to get our residuals or errors, all we have to do is subtract the two. And then if we plot our errors, we can see the spread of our residuals. At one point, we were off by as much as 400 pounds. Then we can calculate the mean squared error to get an idea of how well the model performed. I was trying to square the errors first, but I forgot to write the 2, so now it should work. And let's get the mean squared error for our original training dataset as well. As expected, it performed a little worse out of sample, because that new information was not taken into consideration when building the model. In this lesson, we went deeper into linear regressions and how to extract specific information. We also discussed how to split up the dataset into training and testing datasets to help validate the model information and predictive power.